Okay, I'm going to solve problem 10. This question is about coterminal angles, and I put this fact here that you can always produce coterminal angles by adding or subtracting 360 degrees, and you can keep doing that as many times as you want. So what they want me to do is produce an angle that's between 0 and 360, so that means in the first revolution around the circle, and they want it to be coterminal with negative 135 degrees. So I'm just going to start adding 360 degrees until I end up in this range. I don't think I'm going to have to do it very many times. So negative 135, that's what they give me, and then I'm going to start adding 360. So once I add it one time, I get 225 degrees. So that's 225 is right here. So you can either get to this angle, you'll have two coterminal angles if you go this way 225 degrees, or if you go this way, because I'm opening in the clockwise direction, negative 135 degrees. You'll have two coterminal angles there. Okay, so now we're asked to draw the angle 270 degrees in standard position. So we're going to start right here, and we're going to open all the way down here to 270 degrees down here. So that means 270 degrees in standard position is going to look like this. So here's the initial side, and down there is the terminal side. So really the intent of this exercise is for you to just start to familiarize yourself with this picture, because we're going to use it a lot in this class. So basically, we start going around and we hit these axes at 90 degrees, 180 degrees, and then 270 degrees. So really do your best to have a good stare at this picture, and so you can start to commit it to memory where all these angles live. Okay, now that we have figured out where this angle lives, where it is in standard position, they ask us some follow-up questions. So since this angle points straight down, if I wanted to find a point that's on the terminal side of this angle, I just need to pick a point that's like on the y-axis but down below the x-axis. So when I look through all of the choices, I see that there's only one, right? This point right here is 0, negative 1, because I went left and right 0 and I went down 1. So this is multiple choice, so just check all the options and see if they're on that line right there. Now, in order to find the distance from that point to the origin, we need to just use the distance formula. The origin is 0, 0. So that's really going to make this distance formula calculation easy. They ask us to name another angle that's coterminal with this. So you can just, again, start adding or subtracting 360. So it looks like what they did was subtract. So you could do 270 minus 360, and that's how they came up with that negative 90. Okay, so this is problem 15. It's a bit of a trick question here. I did one of these in class, but this is a bit different. We're asked to find all 6 trigonometric functions, and then they give us this point right here. So where is this point? So 0, negative 5 is down here. And this is the x, and this is the y. So first let's calculate the r. So r squared here equals 0 squared plus negative 5 squared. So r squared equals 25. So technically we should have r equals plus or minus 5 when we take the square root of both sides. But remember, r is defined to be a distance, so it's always positive. So in this example, r is going to be 5. Okay, seems easy enough so far. So now let's try to do these trig functions of where we have these x's and y's, and see if anything goes wrong here. So the definition of sine is y over r. So that is negative 5 over 5. So that's negative 1. The definition of cosine is x over r. So that is 0 over 5. So remember, 0 over 5 is allowed, but 5 over 0, that's what's not allowed. So this is fine. 0 divided by 5 is 0. Okay, now tangent. So tangent is y over x. Oh, and you can see this is when we run into a problem. This will be negative 5 divided by 0, which is undefined. So that's fine. I mean, it's just the answer. The answer is undefined. So just heads up on that. If you have a point that lives on one of these coordinate axes, then it's very likely that tangent or perhaps cotangent could be undefined. Now, sine and cosine, that's never going to happen because they always have r's in the denominator, and r is always a positive amount. So that kind of undefined weird thing can't happen with sine and cotangent. This time cotangent is defined, but it's possible for tangent and cotangent to be undefined. So just be careful when you're doing this. If you get a 0 on the bottom, the answer is undefined. Okay, I'm looking at question 16 here, and that is it's a calculator problem. So they give us an angle, and since both the x and y are positive, that means I had to go right and up. So this must mean that theta is in quadrant 1. Okay. All right, so it's basically like over 9 and then up 7 or so. So here's our point, 9.31, 7.02, and they ask us to round our answers to 4 decimal places. So I'm going to do my best to have the calculator keep as many decimal places as I can, and then right at the end round it if necessary. So here's the ray, and there's the angle theta. And then this x right here is 9.31, and the y is 7.02. So to figure out sine and cosine, I need to know what r is. So, you know, this is just standard business here. R squared is x squared plus y squared. Okay, 9.31 squared plus 7.02 squared. Okay, and that gives me this kind of long decimal that has 4 decimal places in it. And then I'm going to square root that answer. All right, let me try again. So 11.6600, right? And then I'm looking at the next decimal place to decide if I need to round up or not. Since it's a 3 is less than 5, so I'm going to round it down. So in this 11.66, so in my problem, r is approximately equal to 11.6600. And I'm going to keep those 2 zeros just to remind myself that that's how far out I went before I stopped rounding. So now sine of theta here is y over r. So that's going to be 7.02 over 11.6600. 7.02 divided by 11.6600. And I get 0.6020. And then I look one more decimal place, and that's a 5. So that means I need to round that 0 up. 6021. So this is 6.602 and then a 1 because I rounded it up. Question 17 is about where an angle could possibly terminate. So this really, the numerical information here, it doesn't matter. It doesn't matter that it's a 9 and a 41. Really what matters is whether or not that number is positive or negative. So remember, sine is y over r, okay? And cosine is x over r. Remember, r is always positive. So the only way that sine or cosine could be positive or negative, it depends entirely on whether or not x or y is positive or negative. So let's just go through each of these quadrants and decide in which one is the x positive and the y positive, which ones are they negative. Okay, so to get to quadrant 1, I would have to go right and up. Okay, so to go right, the x would be positive, and to go up, the y would be positive. So that means this one is a plus and a plus. Okay, both the x's and the y's are positive. Okay, so to get over to quadrant 2, I would have to go left and up. Okay, so in order to go left, the x coordinate would have to be negative, and the y coordinate would have to be positive. Okay, now to get into quadrant 3, I would have to go left and then down. Okay, so this is like as negative as it could possibly be, right? So over here, to go left, the x coordinate would have to be negative, and to go down, the y coordinate would have to be negative. So both of these in the third quadrant are negative. Now to get into the fourth quadrant, I would have to go right and down. So to go right, the x would have to be positive, and to go down, the y would have to be negative. Okay, so that means x would have to be positive and y would have to be negative. Okay, so what this means is, let's look at the places. So we are given that sine is positive. Okay, so let's look at all the different places where sine is positive. So the only way that sine could be positive is if the y coordinate is positive, because r is always positive. So in quadrant 1, y is positive, and in quadrant 2, y is positive. Quadrants 3 and quadrants 4 are ruled out because in both of those quadrants, the y coordinate is negative. So based on the information that I'm given here, I can conclude that theta could be in quadrant 1 or theta could be in quadrant 2. Okay, so I encourage you to think about this and try to decide which trig functions could be positive in which quadrants. Probably the really interesting one is what happens to tangent in quadrant 3. Okay, tangent is y over x, and in quadrant 3, they're both negative. So remember, a negative divided by a negative is positive. So this is just a bit weird. That's why I'm focusing on this one, because this one's kind of strange. It's counterintuitive. You wouldn't think that anything would be positive down there in quadrant 3 because everything's negative. But actually, tangent theta is positive down here because a negative divided by a negative will give you a positive. So, you guys are all adults, just put your thinking caps on and understand how going up, right and left and up and down works. And you can figure out what quadrant theta has to be in based on whether or not sine is positive or cosine is positive or tangent is positive.